Voice is the most natural interface for communication. It's efficient. People talk much faster than they type, so it's great for those long forms. It's hands-free, which means you can do other work while you speak and while you listen. It's how we communicate by default. I think this is more important than I think people realize. I actually yell at my cursor agent rather than typing it because I find it lets the feedback flow a little bit more naturally. But beyond that, I think it's also great for support. It helps people sort of really describe what they mean, especially for long form interactions like support or if you need help. And the last one is it's universal. Everyone speaks some language, and so it's a great way to sort of bring technology to everybody. If you're paying attention to the space, you might have heard this is the year for voice agents. I think this is true for a few reasons. One, a lot of the models that were not good enough are good enough, and I think we're starting to see really large adoption across many businesses and across different industries, especially finance, healthcare, and then SaaS, of course, and then I think customer goods are all places where I think we've seen a lot of adoption, and on all different parts of their business. So it's starting to become like a big platform on which businesses run. One big area, of course, is AI customer support. So this can be anything from answering questions that customers have about your product to sort of giving people technical support where they need help, and even doctors checking in on patients. Another big one is sort of scaling sales and outbound. A big limitation here historically has been people, and now you can sort of scale your intake inbound 10 to 100x and do better qualification as well. The other big place, which I think is a little bit smaller than the rest but emerging, is on recruiting and training. Specifically for industries where you might need to recruit a lot of people or even save the burden of initial interview screens. I think we've been seeing a lot of initial screening move to AI, and increasingly also training and coaching. So this is things like doing mock sales calls with your sales reps, even therapy. We've started to see a lot of traction for. And the last one, of course, is building the next generation of assistants and companions. If you have a phone, you've probably used one of the last generations of voice agents. It doesn't sound very good. It's also not very smart. I think that's going to change very soon. It should be very natural. You should be able to speak to it like a person. And of course, with all the advancements in AI, it should be much more capable than it's ever been. So while voice can be the most natural interface, it's also one of the most difficult to get right. Rather than having seconds or minutes, or I've had interactions with the thinking models that take like 10 minutes now. You really only have milliseconds, not seconds, to respond. When people talk to a voice agent, typically they find that when the turn takes longer than 500 milliseconds, it feels like they're not talking to a real person and they're not being listened to. And this, I think, drives the fundamental trade-off between speed and capability. So how fast you respond, but a lot of the models today are actually not smart enough to do the next turn in just one shot. And so how do you really balance the amount of computation and reasoning and tool calling that you need in order to generate an intelligent next turn with fast responses? And the last one is conversation quality is subjective and very hard to evaluate. How do you sort of quantify how much does someone like a voice? How did they like the conversation? How was the interaction? I think it's easy to sort of measure top-line agent metrics, but sort of to drill down beyond that, I think requires a lot of human input and is quite difficult. Wrong button. So I think to maybe help you understand a little bit better what the challenges and solutions look like today, I'm going to sort of talk you through today's voice agent stack. There's a lot of things on this page, but I think at a high level, there's a transport layer, which is responsible for getting voice to and from your device. So this could be a phone. This could also be your laptop or or even running on your device directly. And I think the core agentic logic sort of is centered around three pieces. The first is a speech-to-text model, STT. Its job is to take what the user says and transcribe it into text, so that way you know what they said and you can pass it into your language model. The next part is the large language model. Its job is to take in the previous turn of the conversation and produce the next turn of the conversation. Here, I think you'll see a lot of familiar things for those of you who've built chat agents in the past. I think here you need the LLM to have guardrails. You need to do retrieval, do API calls, function calls, MCP. So a lot of sort of the familiar parts of agent building. And when the LLM sort of generates the next turn of the conversation, that goes into the text-to-speech model, whose job is to take what the language model said and render it for the user and send it back to the transport layer. So we'll sort of drill down into these three pieces individually. The first being the speech-to-text part. There's challenges at each layer of the stack. In the speech-to-text layer of the stack, these are the main things I think people have struggled with in the past and need to look out for. The first is sort of how well your model performs in real-world settings. When people talk to their devices, they don't try to make it nice and clean, and so it's pretty annoying. There's a lot of noise. There's a wide range of accents. The telephony stack itself sort of introduces noise and artifacts. And there's a lot of speech disfluencies, like people will say they'll say they'll stutter. And so you'll need to handle those. The other one is like how well this part of the stack handles names, entities, and IDs. These are actually the most important things to get right and the hardest things to get right, especially when it comes to domain-specific vocabulary for your business. So this could be like medication names, your product names, any other industry-specific terms. I think generally pre-trained models will have a more difficult time with things like that. And the last one is endpointing. So how do you, and this is actually a surprisingly important problem here, which is how do you decide when a user is done talking? And so you should send the audio to process the next turn of the conversation. Getting this right is important because if you're too short, the users will tend to feel like they're being interrupted or cut off. And if it's too long, it's just slow and it doesn't feel natural. We just released a streaming speech-to-text product, and I think it highlights a few of the things that we think are really important when looking for products at this part of the stack. The first is speed. It's the fastest streaming speech-to-text. 66 milliseconds is how fast you can expect it these days. We optimized it for the real world, so a lot of speech-to-text models are sort of trained on offline, like batch settings, where you want to do bulk inference of existing speeches and other things. We optimized it for the real world by doing dynamic chunking, so handling the variable length audio, noise, and silence conditions you typically see. And we're releasing new products for fine-tuning and endpointing, which are becoming increasingly important to customize the models for your use case. The next part of the stack is the large language model part. I think here there's slightly different trade-offs with chat agents, and so there's slightly different things to pay attention to. A few are in common, right? Reasoning quality, so guardrails, extended thinking, domain-specific reasoning, and how do you integrate this with your other parts of your stack? So this is things like doing function calling and retrieval. And I think the main thing here is, for a lot of voice agents, the task maybe is not so difficult. It's like, let's take orders, or let's answer questions. But I think the hard thing to keep to sort of trade off with maybe slightly easier tasks than proving math problems is that you need to keep the response time very fast. And so there's a trade-off between reasoning and responsiveness that needs to be made. These are approaches that I think we're excited about on the research side. And we've seen a lot of our customers start to adopt in practice. State space models are actually what we were working on during our PhDs. They're a new architecture for machine learning that replaces the transformer. And the claim to fame here is that it's linear time at inference rather than quadratic, which allows for efficient inference and long context reasoning. The next big thing that I think we're seeing is distillation. So today, a lot of people build their voice agent LLM stacks on top of the main large model providers, but this is really slow, especially when you need to chain together multiple calls. So increasingly, we're seeing people do distillation over synthetic data for their voice agent to train small domain-specific models for faster inference. We've sort of published some approaches here in the open source, and you can try it. It's the Lambda series of models. They're transformer models distilled into state space models. And the last piece is sort of figuring out new ways to do agentic orchestration. One pattern that we've seen work really well in this type of real-time multimodal use case is trying to separate the fast conversations from the larger scale supervision. So you might have a conversation node, which is responsible for something simple like talk to the user and figure out what their problem is. And it'll sort of like route that problem to a LM that can run slower and with more thinking and more tool calling, which sort of determines where you are in the conversation and what the next goal of the conversation should be. And finally, it's the text-to-speech part. Common challenges people see in the text-to-speech model, and you'll see with a lot of sort of generative media models, is hallucinations. Here, I think the models might sound really good in general, but the key is sort of evaluating the parts that are actually difficult, which is how well does your text-to-speech model perform on pronouncing proper nouns, alphanumerics, long and repetitive transcripts, where you'll often see that the model might repeat a number, which is a big issue when it comes to conveying IDs, credit card numbers, things like that. The other one, again, is pronunciation. How do you pronounce domain-specific terms like your company name? And the last one, which I think is more subjective and difficult to measure, is voice quality. So does it preserve the accent that you want it to have? Is it natural? Does it have the right pacing when it talks? Is it emotive and responsive to the user? These are hard to measure without people, but things that I think are really important to keep track of. It's been surprising to us how much the voice that you choose affects the engagement for your voice agent. This is probably where we at Cartesia have been the most well-known historically for Sonic, which is our text-to-speech model. It's the fastest streaming text-to-speech with 40 millisecond time to first audio. We really designed the architecture to try to handle complex transcripts. So these are things like IDs, spellings, phone numbers, lists. And in order to sort of customize pronunciation, we've also worked on phoneme overrides, so allowing users to just say exactly how something should be said. And we've conducted a lot of human studies. That's the best way I know of so far to sort of get a sense for what voices are good. Actually, Labelbox just came out with an independent evaluation for us, and I think we're doing really well. And in general, I think like getting voice models that are natural, they're context aware of what's being said, with high speaker similarity, so it sounds like the person that you're trying to clone. So this is the stack. It's a little complicated, but I think you should have a pretty good picture of what that looks like today. And I think as a summary, building best-in-class voice agents requires innovating at every layer of the stack. So what we're seeing is fast co-located models to reduce latency and make time for reasoning. Increasingly, people are starting to use their own fine-tuned and distilled models to improve domain-specific performance, especially at fast inference speeds. Building new patterns for agentic orchestration, like decoupling the conversation and supervision, and figuring out how to rigorously evaluate both subjectively and objectively something like a voice agent, from things like deflection rates all the way down to sort of voice preference scores, and even having agents that you build to talk to one another. So I'll pause there, and I think we'll sort of transition a little bit into what the next generation of research will look like. So we've talked a little bit about what best-in-class voice agents look like today, and probably will for the next while. But I think I think the really interesting thing here is like, how do we see this evolving as we and other labs maybe release new models? And for us, our belief is in the long run, end-to-end voice models will enable the next level of realism. Instead of sort of cascading 3 models, you'll have one model that directly takes audio in and predicts the audio that it should be saying, without having to go through a speech-to-text, an LLM, and a text-to-speech. We think this is important for 3 reasons. It will let the model be more empathetic to emotion and tone. It'll understand exactly how the user said something and try to say something back that fits the right emotional tone. It'll give you faster latency and responsiveness because it's all one model. And the last thing is, I think you should be able to achieve better conversational flow with natural back-channeling and interruptions. Real conversations aren't always turn-taking. And so, I think like this type of research, I think will be increasingly important as voice agents get large adoption. I'll share 2 directions that we're working on at Cartesia. The first is building new architectures for end-to-end voice models. If you've been following the space, you might have seen some preview models like OpenAI Realtime or Sesame. They sound really good, and I think and kind of show what the next stage of voice realism might look like. A lot of these are actually half duplex, to the best of my knowledge. They actually function very similarly to today's stack, where they take an audio and then they pass it to a speech language model, which then generates audio for the next turn of the conversation. So it's sort of, it's very similar to the models we have today. I think the next sort of North Star will be full duplex voice models. These are models that constantly stream input audio from the user and constantly stream voice agent output out to the user. This means that the agent is always listening. It can respond and interact with you where necessary. It can even interrupt you the way that you do when you get in a heated conversation. And this is, I think, the most general way that you can model this type of conversation. And so increasingly, I think the research will sort of focus on building models like this. And right now, I would say the big blocker and why most voice agents aren't built on end-to-end voice models is the reasoning is just not that good. And at some point, you care more that your voice agent is smart than exactly how it sounds. And so a lot of the research we're doing is trying to figure out how do you unlock better reasoning for end-to-end voice models. And this is along 3 directions. The first is controllability. So how do you steer and audit model outputs to sort of understand the same way that you can when you have an LLM who you can monitor and apply guardrails on before speaking. The second is how do you combine sort of the fast streaming speech models with extended thinking, which is required for getting intelligent next-turn reasoning. And the last one is how do you then integrate this with all of your tools, function calling, API calling, RAG, and things like that. Thanks.